All right. So we'll continue. So in the previous class, we have seen the Gauss-Seidel method, and we have taken only one problem based on the Gauss-Seidel method, and this was a 4 by 4 matrix. Okay. In the previous problem, we have chosen all the guess roots as 1, 1, 1, 1, right? So see, the thing is like this: you can start with any guess root. Okay, you can start with all zeros. You can start with all ones. Today we are going to solve a simple 3 by 3 matrix, but this time I'll be choosing a different root. Okay, so for one root the value will be different. For second root the value will be different, and third root value will be different. So this is also going to work in the Gauss-Seidel method. Okay. So for this purpose, I'll be just taking a simple 3 by 3 matrix. Okay. I have already solved this problem using 3 by 3 matrix. So the matrix is something like this. So we have a simple 3 by 3 matrix with coefficients like this is 4, 1, 2. Okay. Then we have 2, minus 2, and 2. So this is 2, minus 2, and 2. Then we have 1, again minus 2, and we have 4. This is multiplied by unknown constant, let us say x1, x2, and x3 equals to, let us say we have this is 21, this is 8, and 16. Okay, so this is a simple 3 by 3 matrix, and now we have to find out what is the solution of this using the Gauss-Seidel method, which is a iterative type of a method, and this time we'll be using a different roots. Okay, so to begin with, what we have to do first, we have to write down the expressions in terms of x1, x2, and x3. Okay, so if I expand these matrix into a equation form, you are going to get three equations. One is 4 times x1 plus 1 times x2 plus 2 times x3 equals to say 21. Then we have 2 x1 minus 2 x2 plus 2 times x3 equals to 8, and lastly 1 x1 minus 2 x2 plus 4 times x3 equals to 16, right? So these are the three equations which we can generate by the multiplying the respective rows and columns from the equation. Okay, so now let us call this as equation 1, this as equation 2, and this as equation number 3. So I can rewrite equation number 1 in form of x1. Okay, so if you rewrite the equation 1 for x1, so this will be minus x2, sorry, this will be first of all 21, okay, minus 1 times x2 minus 2 times x3 whole. Okay, so let us keep it rectangular bracket, whole divided by 4. Is it okay? Okay. Now in the similar way, you can rewrite expression number 2 in terms of x2. So x2 can be calculated as 8 minus 2 times x1, okay, minus 2 times x3 whole divided by minus 2. Okay, and equation number 3 can be written as x3 equals to, this is a square bracket, and then we can have this is 16 minus 1 times x1, then minus of minus, so this will become plus 2 times x2 whole divided by 4. So now you have three equations. One is A, one is B, and one is C. So now using these three equations, now you can start with the Gauss-Seidel method. So let me use a simple table for this. Okay, because with the help of table it becomes easy. Okay, so let us say I have inserted this table over here. Okay, so let me increase the font, otherwise the values will not be visible. Okay, so here I am going for, let us say, guess roots. Okay, so in the previous class we have seen the guess roots. All guess roots we have taken as same. Okay, same. So you can start with all 1, all 0. So this time I'll be going with something like 1, 2, and 3. So not necessary that we should take all the values. Even you can take the negative values also. Okay, not necessary that every time you should take positive. You can take negative values also. Now here iteration 1. Okay, so now if you use this iteration 1, okay, so here rather I should put it in different way. These are the guess roots. Okay, so I'll put it here. Okay, uh, I'll change this as x1, this is x2, and this is x3. Okay, then I'm going to write down over here iteration 1. Okay, so now with the help of equation 1, that is x1, sorry, equation A, that is 21 minus x2 minus 2 times x3. Can you give me the value of x1, please? 3.25. Okay, someone please cross check this whether it is correct or not. Barabar hai? Okay, so now with the help of this equation B, okay, so equation B is x2 equals to 8 minus 2 times x1 minus 2 times x3. So in that x1 has to be taken as 3.25, which is the latest value, and your x3 has to be taken as the 3, which was assumed. So can you give me x2 please? 2.25. Okay. About x3 then? 4.3125. Please cross check someone. Okay. So see, it's a completely mechanical process. Okay. Not much has to be done. Okay. So can you go for iteration 2 now? I know the answer, but now I want all of you to solve this. Online students, please do the calculations, and if you have any queries, please let me know. Okay. Yes, after iteration 2, anyone? Sorry? 2.531. Okay. How about this one? टू पॉइंट आगे 2 डिजिट 8443. अच्छा 8443. Okay. Lastly, 4 point आगे 2 डिजिट 78. That's it. 788 और एक डिजिट 7. Yes, someone please verify. Is it correct? 7893. Is it okay now? 7893. देखो सब लोग अगर ये डिजिट यूज करेंगे ना तो कंसिस्टेंसी रहेगी रिजल्ट में. Okay, so you see, after the first iteration we got these values. Okay, and if you compare the values of second iteration with the first iteration, you will find nothing is matching. है ना? Because if you compare the value of x1, it is 3.25, and in the second iteration it is 2.5. So there is a great difference between the values which we have obtained in first iteration and the second iteration. So now we have to keep on increasing the iteration. So this will be iteration 3. Okay. 2.1445. Someone please cross check. Okay. Next. X2 value, anyone? 2.93. Okay. Last. Yes, everyone is on. Okay. So now we see our solution is converging. Okay. Converging means what? It is approaching towards the correct solution. So now you can see it was 3.25, then it become 2.5, then now it is becoming 2. So it is slowly reducing. And if you see the x2 value, slowly it is increasing. And if you see the x3 value, slowly also it is now increasing. Okay. So now again, if you compare the values of iteration 2 and iteration 3, they are not at all matching even after the decimal point. Okay. So we have to go for more iterations. So इस problem में although it is 3 by 3 matrix, the iterations required they are increased. In the previous, I think we have gone for just 5 iterations. Okay, even after third iteration we got the answer, isn't it? But if you see this problem is even smaller in size. It's a 3 by 3. Earlier one it was 4 by 4. So even if it is smaller in size, we are not approaching toward the correct solution even after the third iteration. Okay. So like I said earlier, this particular method totally depends on the values which are there in the matrix. Okay. Secondly, what value of guess root you are choosing. Okay. Because of that, you can see now there is a increasing number of iterations. Anyone iteration 4? 2 point? Sorry? 05? 13. Okay. 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 So now, just compare the values of iteration 3 and iteration 4. So you can see the value of x2 and x3. They are almost same as far as the decimal, one digit after the decimal is concerned. Okay, so it is 4.9, 4.9. This is 2.9, 2.9. Here it is 2.1 and it is 2.05. Okay, so now your picture is getting clear where will be the solution. But for this, it took almost 4 iterations. Otherwise, in the previous problem, after 4 iteration, you are very much closer to the actual solution. Okay, so this is the main disadvantage you can say for the Gauss-Seidel method, because it is totally depending on the data which is there in the matrix and the guess roots. Okay, please try for one more iteration. Sorry, 5, 4. Is it same? Good. 2.9935. Is it so? Correct. So now you see, yes, we are coming closer to the solution. Any guesses what will be the final answer? 2, 3 and 5. Okay. Go for one more iterations. 2.51. Okay. 2.99. Okay. 4.99. Yes. Okay. So yes, now I can say that the values which are there after iteration 6, they can be a final answer, but still they are not the final answer because final answer is 2.2, 3 and 5. Okay, I hope this is understood to you. Okay, so now uh, let me show my entire screen. Okay, so now so this is the program which is written in C language for solution of uh, this equation using the Gauss-Seidel method. Okay. So now, because manually it is taking time, that's why I'm showing you on computer program. So it says how many number of equations? Okay, I have only three equations. So matrix A is something like 4, 1, and 2. The second is something like 2, minus 2, and 2. Third one is 1, minus 2, and 4, I suppose. Yes, sir. Okay. And the vector is something like 21, 8, and 16. Okay. So we have chosen a guess root as 1, 2, and 3. So you see how many iterations it took. If you count, so we are getting the right answer somewhere over here. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it took 14 iterations to get the exact answer. Okay. So again, I am repeating, this is only because it is totally depending on the data. Okay. If your data is changed, everything is going to change. So kitne iterations lage? 14. Okay. Now I am going to run the program once again, but this time I am going to choose different guess values. Okay. So let me execute this one more time. So I have only three number of equations with me. So this is 4, 1, and 2. Then we have 2, minus 2, and 2. And lastly, I think we have 1, minus 2, and 4. Barabar hai? And then we have 21, then we have 8, and then we have 16. Okay. So this time, if I choose this root as 1, 1, 1. Okay. So 1, 1, and 1. So you see, अभी देखो काउंट करो कितने इक्वेशंस लग रहा है. Okay, here, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. पहले कितने लगेंगे? Whatever. So you see, it changes. Okay. So depending on the guess roots, if I run the program once again, and if I choose the roots which are very close to the actual solution. So actual solution is something like 2, 3, and 5, isn't it? So in place of that, if I go for 3, 3, 3, okay. So I'm sure you will be getting a quicker solution. So like we have 4, then we have 1, then we have 2, then I think we have 2, minus 2, and 2, then 1, minus 2, and then 4. The vectors are like 21, 8, and 16. And this time if I choose 3, 3, and 3. So the middle one, that is x2, is the exact answer. X1 actual answer is 2, but I am choosing 3. Here x3 is 5, but I am choosing 3. So you see यहाँ पर शायद तुमको iterations कम मिलेंगे. We can count. Okay, so this is the final estimation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. इतने ही करते हैं. ठीक है. So it totally depends on the data now. And believe me, although on the screen you are saying 5.000, you can see only 6 zeros. Okay, but if you know the C programming, we have a %f format, right? So in the %f format, you can define how many decimals has to be printed after the decimal point. So if you print 10 decimals, I am sure you will find some values which are beyond that. Okay, so this is how this Gauss-Seidel method is working. So you have to decide where you have to stop. So you have to make a judgment. Okay, unless and until you take that judgment, you have to keep on repeating again and again, again and again. And if someone is using some different routes, so he or she may be getting quicker answer, the other may take even more answer. Okay, so this is how the Gauss-Seidel method is working. I hope this is clear to everybody now. Okay, so this is completing the Gauss-Seidel method now, and we will be continuing in the next class, because in next class I have to start with the uh, new topic. Okay, so please attend next class. So